All right, so there were some really good news this week. The IEEE Ottawa Robotics Competition is actually going to happen this year. If you haven't heard about it before, it is a fun event with good prizes, which usually occurs at the end of May. This year, it is scheduled on May 29th, and it's going to be virtual. Usually, they offer multiple challenges for several robotic platforms. This year, there will be only 3 challenges for 3 platforms, Microbit, Lego, and Arduino. A good thing about having this competition virtual is that it's not limited to participants from Ottawa. It can be Ontario-wide, Canada-wide, and even worldwide. And I'm going to give a quick overview of the challenges. The Arduino LRT Detour challenge. This is a maze solving challenge using make block mbot, which I have here. It is a popular Arduino robot. Normally, it is for students with good programming skill from grade 7 and up. And the rules of competition are available here. The rules state, this year the rules state that teams are expected to send their robot's code before the day of the competition. It probably means that the competition organizers are going to run your code themselves. This actually creates a number of problems. The first problem is that mbot has 2 motor ports here, and 4 sensor ports here, which gives you multiple possibilities to connect motors, ultrasonic sensor, line follower, other sensors or displays that you may have. In other words, the program that may work fine on your robot with your sensor, motor, and port configurations may not work at all on the robot assembled by event organizers, which may have different configuration. This problem can be solved if the event organizers can specify wiring instructions in their rules, or include a requirement that the robots have to be assembled using the default schematics. And these schematics are included in the user manual, which should be okay, give me a second. Yeah, it should be here. Yeah, this is how default mbots are assembled. The second problem is that mbot is an educational robot, which implies that the quality of parts is not very good. It means that the same program that may work differently on different instances of a robot. For example, to solve a maze, you need to detect intersections of a maze with high accuracy. This is what the maze looks like, or will look like, with no obstacles. And the intersections are places where the lines of a maze cross, and both sensors of a line following sensor detect black color. However, some of the mbots may wrongly detect intersections when it just follows the line. And it happens because the sensors on the line following sensor are too close to each other. Here. And this problem is not consistent. For example, the mbot that I have at home is not affected, but the 5 robots that we have at school are all affected by this problem. And there are multiple ways to fix it. The first way is to use a line follower array, which has 6 sensors instead of 2. The next way is to use 2 line follower sensors, kind of like this. But these 2 solutions may not work this year because it's not clear whether event organizers are going to modify a standard configuration of MBOT. Another option is reducing diameter of a front wheel, of this wheel. It brings the line following sensors closer to the surface, and they become more accurate. We tested this solution at school when we prepared to the competition in 2020. A link to the 3D model of the front wheel will be posted in the description of this video. This may be the best option if event organizers could agree to 3D print a front wheel installed for everyone or upon instructions from specific teams. Another challenge is the Vinci Lego challenge. This here. So in here, you need to build a robot using the Lego EV3 robotic kit to draw an artwork. And the theme of the artwork for this year is famous buildings. Keep in mind that in order to draw good artwork, you need to address a number of mechanical issues to make your robot very accurate. In other words, mechanical design is a key in this challenge. Here are the examples of the drawings that were created in the past years. This robot has a good mechanical design. This one here. And this is a picture from 2019. Here's another one from 2018. You can find more pictures on Ottawa Robotics Competition Facebook page. The last challenge is the Microbit Mixtape challenge. So this is what a microbit board looks like. But you don't even need it to participate in the challenge. You can use the simulator as described in the challenge rules. In fact, programming a microbit is very similar to programming of web pages that I'm explaining in my sessions. For example, the microbit board has 2 buttons. And these buttons are handled in the same way as we handle buttons for our web pages, so using event handlers. And by the way, handling button events is a requirement for the Microbit challenge. In addition, Microbit allows programming it in Python and JavaScript, in addition to Scratch blocks. You can also switch between blocks, JavaScript, and Python. So in here, we can switch from blocks to JavaScript and to Python. Your code will be automatically converted. Also, programming Microbit and JavaScript solves some of the problems that exist when you program it in blocks. And I'm going to show you an example. So here I'm going to paste a Microbit program that plays Jingle Bells. We created it with my sister and her friends just before Christmas. Now, if we start the simulator and click the A button, it should play Jingle Bells. However, if I switch to blocks, it says invalid input because it cannot recognize F sharp, D5, E5, G5, B4, and G4, although it recognizes C5. However, even if I remove suffixes that Microbit blocks don't recognize, just like I did here, and go back to blocks, it shrinks the melody to just 8 notes and does not recover it when I switch it back to JavaScript or Python. Just keep this in mind when you'll be creating your melody for the challenge. Anyway, if you're interested to attend this robotic competition, I would recommend attending their workshops. And there's usually one workshop for each challenge. In my next sessions, I'm going to continue explaining basics of JavaScript with a focus on commands and features that you may need to create a good program for the Microbit or C challenge. Then I will cover some specifics of programming Microbit. So we have some time left. And today I'm going to continue explaining JavaScript commands. This time I will explain you loops. You may remember that at the end of a previous lesson, Alice asked me to animate the sliders, and I demonstrated you some code. And today I'm going to show you how to do it. Last time we learned that color changes from 0 to 255. And what if we would like a red slider to move in that range and show us all colors? First of all, we'll need to create a button that will initiate this action. This is a button which says move red slider on it. And when you click on it, it calls this function. However, when we refresh the page, you'll see that the button has appeared on it, but when we click on it, oh, sorry. I forgot to undo the code from when I was actually testing this lesson. When we click on it, we're going to see an error, and that is because the moves red slider function is not defined. We haven't actually made it yet. In order for it to work, we need to actually create the function. And I already made the function ahead of time. And in this function, we just set the value of a red slider to 0. So move it to the leftmost position. And here we have a while loop. So in this while loop pretty much repeats everything inside of these brackets. So these 2 lines of code, while the condition here is true. So here, while the value of a red slider is less than 255, which is its max position, we increase the value of the red slider by 1, and then update the background color. So these 2 pluses are a command in JavaScript which increases the value of this variable by 1. And there are 2 other ways to write it. One of them is our value plus equals 1. This just means take the value of r and add this number to it. And there's also, and that is the short form for this form, which is just take the value of r, add 1 to it, and write it into the value of r. However, the ++r.value is the shortest and most efficient, and we'll always use it in the future. Now, when we save and refresh the code, you'll notice that it moves the slider all the way instantly. And that is because, and we don't see the gradual change. And that is because the while loop runs very fast, and JavaScript the browser just doesn't have a chance to actually redraw the background every iteration. Even though if we look in the console, we actually go from 1 to 255 in here. To fix that, we need to add some sort of way for the while loop to pause or for a certain amount of time every iteration, so the browser actually has a chance to catch up. In other programming languages, there's usually a function, a built-in function, which makes the program wait for a certain amount of time. So in C++, for example, there's a function called sleep, which makes a program wait for a certain amount of milliseconds. And there's a similar function in Microbit, except it's called pause. And it waits for a certain amount of milliseconds. Now, JavaScript doesn't have such function, so I actually coded my own. So this function just waits for a certain amount of milliseconds. And here we're going to write this. And so what that means is call this function, make the program stop for 10 milliseconds. And this keyword just means wait for this function to complete before actually continuing. And if we're using the await keyword, we need to specify that the function is async and write the async keyword. Now, if we save and refresh the code, you'll notice that the change is a lot more gradual. Now, we did this using the while loop, but there's another type of loop in JavaScript called a for loop. So the easiest way to change the while loop to a for loop is do this and add 2 semicolons like this. And it should still work the same way. The difference is the for loop, unlike the while loop, has 3 sort of like segments inside the brackets separated by semicolons. The first segment is a chunk of code which is done before the loop starts. The middle is a condition which is checked every time an iteration of a loop is completed. If this condition is false, then it just exits the loop. And at the end is a segment where you put code which runs every time the for loop completes successfully. So in our case, we could put this line there and this line here. And it should still work the same way. The same while and for loops can also be used in Microbit. So if we go on loops here in Microbit, we can create a while loop, and we can also create a for loop. So here the while has the same kind of idea, has a condition, and while this condition is true, it repeats this loop. In this case, the while loop will be endless because this will be always true. For loop, also same kind of idea, except in here we're actually declaring the variable. And here, r.value already exists, so we don't have to declare it a second time. However, here we actually create the variable I and assign the value of 0. Here, same kind of idea. There's a condition. And then in here, I is incremented. And here, you'll see that the plus plus is actually after the variable instead of before. And that is because it's a second form of writing it. The way I've wrote it here with the 2 plus pluses in front is called the prefix form. And this form here is called the postfix form. Although these two forms have a difference, this difference is not very big or very noticeable. And you'll only see it if you're doing complex mathematical expressions with these increments. I usually use the prefix form because it is generally considered that the prefix form is faster. But the postfix form is also fine. And as you can see, Microbit actually prefers the postfix form. In terms of these loops, we can actually go back to the block view of Microbit. And this is what the pause command, the while loop, and the for loop looks like in the block form. And here we can actually change this, for example, and this, and see how it changes in the JavaScript code. And as you can see here, the value inside the pause function changed. Here, while true changed to while false. And here, it changed the name of the variable for some reason. I don't know why, but it still works the exact same way. Except here it actually goes to 255. So that is all that I want to explain today. Does anyone have any questions? No? I'm guessing that's it for today then. All right, thank you for listening, everyone. Have a good day. And I'll see you next Sunday.